Alright, in this video we're going to be talking about polygons, angles in polygons, and finding missing angles in polygons. So remember, polygons are closed figures that have three or more segments that have exactly two other segments as their endpoints. Remember, a heart is not a polygon because it has a curve, but we could do squares, we could do stars if I could draw a star. Okay, so as long as it doesn't have a curve and is closed, we can call it a polygon. We also have convex and concave. So concave polygons cave in. So it's like if a little person sat inside a cave. Okay, so they cave in. Convex, they don't cave in anywhere. It has no diagonals with points outside the polygon, where if I made diagonals with these points, it would be sitting outside the polygon from corner to corner. Okay, equilateral, equal sides. Equal angular, equal angles. Regular is big in this. It is both. Equal sides and equal angles. That means all the sides match and all the angles match. That's going to be really big with this unit. Okay, so polygon angle sum finds the sum of all the angles in the polygon. So to do this, we do n minus 2 times 180, where n stands for the number of sides. So that finds the total amount of degrees if you added up all the angles in a shape. Okay, so an example of this, when I look at triangles, triangles are 180 degrees and they have three sides. So if I do 3 minus 2 times 180, 3 minus 2 is 1, 1 times 180 is 180 degrees. Okay, testing it with four-sided figures. A square should have 360 degrees. So 4 minus 2 times 180, that gets me 2 times 180, which then gets me that 360. Okay, determining the sum of the angles. So we do 21 minus 2 times 180. My next one we'd be doing 42 minus 2 times 180. 50 minus 2 times 180. Okay, so my first one we would get 3,420 degrees to share between those 21 angles. My next one, we would get 7,200 degrees to share between those two angles. And my last one, 8,640 degrees to share. Okay, to find the measure of one angle in a regular figure. Okay, we can do this because all the angles are the same. So first I find my total, and then I divide it by the number of sides to divvy it up between each of those angles. Since they should all be the same, I can divvy it up between all of them. So n minus 2 times 180 divided by that n. N stands for the number of sides again. Okay, so my first one, find the measure of one angle. So it's a regular figure, so I got 1, 2, 3, 4, 5, 6 sides. So I do 6 minus 2 times 180, and I want to divvy it up between all of those angles to figure out what one of them is. Okay, so when I type this in my calculator, I get one angle to be 120 degrees. Okay, my next one, we need to find n. So first we need to find the total number of degrees to share, and then we can take off all of these known ones to find what I want left. So first off, I've got 1, 2, 3, 4, 5, 6 sides. So I'm going to do my 6 minus 2 times 180. The reason I can't divvy it up by dividing by 6 is because not all those angles are the same. So my 6 minus 2 times 180, I have 720 degrees to share, and then I need to subtract all these other ones out. So if I wrote it out the long way, it could be all of the angles adding together equaling its total of that 720, where you would now subtract all of them to get rid of it. Okay, in case for some reason these aren't all numbers, they're equations, you have to add all the equations and set it equal to your total and solve. Okay, so when I have my 720, I'm going to subtract them out. And I get n to be 81 degrees. Okay, my next one, 1, 2, 3, four-sided figure, so I already know it's 360, so if I wrote it out the long way, I would be adding all of them and setting it equal to 360. So 360 minus that 37 minus that 44 minus 152. I've got my n to be 127 degrees. Okay, my next one, 1, 2, 3, 4, 5, 6, 7, 8 sides, so 8 minus 2 times 180. I've got 1080 to share, and I'm going to subtract 99, 147, 145, 122, 139, 147, and 141, and I get my n to be 140 degrees. Okay, exterior angles. If you think about it, exterior angles are kind of like what make up our circle here. So if I extended all my lines, these are all my exterior angles. They're angles that sit on the outside of my polygon, and they make up basically a circle. So if I added all of them together, they would always be 360. So if this was a regular figure, and I wanted to find one of them, well, I have 5 angles that I'm trying to divvy it up between. So I do 360 divided by those number of sides. So each of those exterior angles, if it's a regular figure, would be 72. So that outside angle would be, that outside angle would be 72, this outside angle would be 72. Okay, here we're just filling in some missing pieces. So I've got my 120, I got my 81, looks like I'm missing my 72 in this. And if I add them all up, they should equal 360. My next one, I've got my 90, I'm missing my 56. I add them all up, they should equal 360.